Hi, I'm going to be making a Bluetooth MIDI sequencer with an ESP32. First off, for a moderately complex project like this, an RTOS is a must, because we're going to have multiple processes going on. We're going to need the handling of input events, we're going to need the rendering of the display, we're going to need the queuing up of MIDI messages to be sent, and we're going to need the maintaining of a Bluetooth connection. So here is my display task, which handles the SPI connection to the display and does all of the rendering as per the context of the application. Moving on, here is my input task, which handles the I2² connection to the touch input driver, and then checks to see if a user touch event is registered to be handled in a specific context. Here is the MIDI player task, which is built around a queue. It controls the scheduling of sending MIDI notes as per the BPM setting of the sequencer. So we keep track of the time as per the BPM, and then if a MIDI note is to be sent, that MIDI note data gets chucked onto a queue. And then lastly, we have the task which handles the Bluetooth connection. So that will automatically try to find a Bluetooth low energy device. Here's the service UUID for a Bluetooth MIDI device, and here is the Bluetooth characteristic that gets written to. And then with the Bluetooth connection established, the logic is built around a queue. So MIDI messages get queued up, and then in this loop here, those queued up messages get dequeued and then sent to the Bluetooth device. Originally, I had planned on using a USB connection to send MIDI data, but I found that I was unable to power my device at the same time as sending MIDI data, which would mean I'd have to externally power the ESP32 or use some sort of battery system, and that's why I chose to look at Bluetooth MIDI. So now it's time to look at the MIDI specification. The MIDI specification is surprisingly simple. Here is the basic structure, the header, and then we have payload data. And here we can see the definition of the header data. Here's a note on message. We've got the high 4 bits of the header byte equal to 9. The low 4 bits equal to 0, meaning that it's channel number 1. And then we have the first byte of the payload indicating the MIDI key. In this case it's middle C. And then the last byte of the payload is the note velocity. Here we have a note off event. The high 4 bits of the header byte is equal to 8, and the low 4 bits of the header byte is equal to 0. And then again, the first byte of the payload is equal to the MIDI key, and the last byte of the payload is equal to the note velocity. And then here we have a controller change indicated by the high 4 bits of the header byte equal to hex B, and the low 4 bits of the header byte equal to the MIDI channel, in this case MIDI channel 1. And then the first byte of the payload indicates what control is being changed, and then the last byte of the payload indicates the value to change that controller to. So in my MIDI sequencer, I just chose to work with this basic small set of control change messages. The display driver I'm working with is the very common ST7789. And on AliExpress, display modules are readily available, and they also come with touch. So I'm using the 2.4-inch display with a touch driver. For the Bluetooth connection, I'm using the Bluetooth Low Energy library NIM-BLE. NIM-BLE is a completely open source Bluetooth Low Energy stack produced by Apache. we look in the Arduino IDE, we've got all of these examples for NIM BLE that we can then flesh out and build upon. To finish off the device, I thought it would be nice to package it in a Eurorack form factor. I went about trying to find the appropriate hole spacings and measurements, and then in FreeCAD draw up something that's appropriate for housing this sequencer. And then it's just a case of getting it 3D printed. So the main context of the device is a sequencer with a play and pause button. Then we have basic settings where we can change the BPM either with this slider or with the left and right arrows. We can change the root key and we can change the number of bars. Then if we go back to the sequencer, we've got another screen to draw a sequence pattern on. So at 2 velocities, if you touch a square twice, it toggles the velocity value. And you can switch between minor or major. And I've got a reset to clear the sequencer pattern. Then the next screen, I've got some control values. Unfortunately, my MIDI device isn't that good, so it's hard to hear these control value changes have an effect on the sound. And my last context is a little QR code. So the Bluetooth connection is done automatically because there is a specific UUID for a Bluetooth MIDI device. If I turn on my Bluetooth MIDI device, we will see this Bluetooth icon change. There we go. In conclusion, this was a fun little project to do. I definitely think a USB MIDI connection would be more reliable than a Bluetooth MIDI connection, but I will get some use out of this ESP MIDI sequencer.